So in this video, I want to cover a topic that I think gives most students a heart attack when they first see it. It's the reduction formulas, and it's related to integration by parts. It's also related to trigonometric integrals. And so I'll show you the reduction formula for sine raised to some power of x. And there it is, and it looks scary, right? And this formula is for when n is greater than or equal to 2. And so we wouldn't use it for anything where n is less than 2, and we don't need it either. If you had n is equal to 1, right, that would just be the integral of sine of x dx. We already know what that is. We don't need any special formula. That's just negative cosine of x, not dx, negative cosine of x, but plus some constant, right? Okay, so why would you even want to try memorizing some beast like this? Well, what if you had sine raised to the 5th power of sine of x, right? That would be a nightmare. And if you tried using integration by parts, this v du, right, you're going to need to probably go through this a couple of times because we need to keep going until the degree goes to 0. So this is why you'd actually want a reduction formula. So you kind of already know the pattern. It's laid out right here in front of you. You just need to know what n is, your power. You plug in for n, you plug in what that number is everywhere, right? And then you'll arrive at some new decreased degree or reduced degree version of your function. And then you can apply it again as many times as you need to until this goes away, until this term becomes, n minus 2 becomes 0, right? And then this term will go away and you'll arrive at your answer. But I agree that this is scary looking. When I first saw it, I was freaked out too. And I couldn't believe that I even had to memorize some of these for sine and for cosine and for, I think, tangent. And or maybe it was secant, something like that. So I want to, the purpose of this video is to show you why this isn't so bad, why it's not so scary. And the way you do that is just by figuring out how they came up with it. And they came up with it using integration by parts. And you might be wondering, how would you use integration by parts when you have just a single function raised to some power? Well, let's go over that real quickly. So first of all, let's kind of get rid of this guy here. And then I want to sort of help you see some of the creativity that's required when you're in Calculus 2 or Calculus BC, whatever you're doing. To solve integrals, because sometimes you have to be a little creative. And if we looked at this right away, let's say you had like sine, to some like 5th power or something, and you just have a single function there. You don't know how to do a u sub to solve that. The u sub gets you nowhere. What are you going to let u equal sine? Okay, but then what's that going to do for you? Nothing. So the only other, up till this point, the only other method is integration by parts. How would you use integration by parts when you have a single function here? Well, when we had ln of x, we said, oh, well, we let 1 equal our function. In this case, that's not helpful either. What we could do, though, what you need to recognize is that sine to the n of x is the same thing as saying sine of x, right, to the n power. And that means sine of x multiplied by itself n times. Well, you can pull one of those out. So if you said one of those signs, we're just going to write here out front, and then we're going to be multiplying by, not n, sine of x to the, well, if you pull one of the signs out, then the power is going to be n minus 1 now. Okay, now we have two functions here, and we could do an integration by parts application. We just have to pick a u and a dv. And hopefully it's pretty clear which one's going to be which, because if we let sine of x be u, right, we know how to differentiate that. That's cool. But then that would mean sine of x to the n minus 1 is our dv. That's the same problem we have here. We don't know how to integrate that. So clearly this right here has to be our u. And you might be wondering, what do you mean we don't know how to integrate it, but we also don't know how to differentiate it? And if you're saying that, I'm saying, yes, you do. This is just some function raised to some power. You know how to do that. You use the simple power rule for differentiation. So if that's our u, then this has to be our dv. So now let's look at how we would differentiate this guy. So if u is equal to sine of x to the n minus 1 power, well, what if this was just some, function here like x raised to the n minus 1? You know how to differentiate that, right? This would be du. You bring the power down in front, so the thing would be n minus 1. The entire thing goes down in front, right? And then this is multiplied by the function itself raised to the, so you have to decrement the power by 1. This would be n minus 1 was already there, and then you'd have to minus 1 again, right? So that ends up being n minus 2 here. And then this is a chain rule type problem. We have an inner function, sine of x. So what is the derivative of sine of x? Well, it's cosine of x. And then du, right? Then this has to have a dx out front. We just, it's du dx, we bring the dx over here. So, okay, it's not a nice looking derivative, but we know how to take it. And then dv we said was just sine of x dx. Well, v is just simply negative cosine of x. It's an x there. So now we can try applying integration by parts. And it's going to be a little bit, busy, but it's not a problem. We can do it. So I want to remind us that we are doing the integral of sine to the n of x dx. And that equals v du. Or sorry, uv, right? So that's negative cosine times sine of x to the n minus 1. So we have negative cosine of x times sine, and I'll write it like that again, to the n minus 1. Okay, minus the integral, and actually I might need a little more space in that, minus the integral of v du. V is negative cosine, so that negative, I'm going to bring that out front, make that plus. So cosine of x times n minus 1, du is n minus 1 times sine of x to the n minus 2 times cosine of x. Oh, wait, we have a cosine of x here too. So that's going to be a cosine of x multiplied by cosine of x. That's cosine squared of x there. This n minus 1 here, that is a constant. So I put it out front, outside of the integral. And then this is multiplied by sine to the n minus 2 of x dx. Okay, this is actually looking kind of like the reduction formula. Not exactly, but we have this sort of thing. We have a negative cosine times sine of n minus 1. We have that. We have this n minus 1 out front. We don't have this division by n yet. And in the integral, we just have a sine to the n minus 2 of x. In the integral we have here, we have this cosine squared of x sort of lurking around. What do we do with that? Well, if you have cosine squared and you have a sine, raised to some power, we can combine this. We can turn this into a function with sines. Why? Because cosine squared of x plus sine squared of x is equal to 1. We should have that memorized from pre-calculus or trigonometry. If you rearrange this, you see that cosine of x is equal to 1 minus sine squared of x, right? If you subtract sine squared of x from both sides, that goes away, and then you have this minus sine squared of x. So why not substitute 1 minus sine squared of x up there? If we do that, right, we're going to have sine to the n of x is equal to negative cosine of x times sine to the n minus 1 of x plus n minus 1. No, not n plus 1. What am I doing? N minus 1 times the integral of. Okay, this is 1 minus sine squared of x times sine to the n minus 2 of x dx. Okay, we can distribute this sine to the n minus 2 of x into both of these terms here. So when we do that, we're going to see that this is negative cosine of x times sine to the n minus 1 of x plus n minus 1 times, we distribute it to the 1, that just gives us sine to the n minus 2 of x. When we distribute it here to the sine squared, let's think about this. So you have sine squared, I'm going to just off to the side, right? This is sine of x to the second power be multiplied by sine of x to the n minus 2. What do you do when you have the same base raised, it's raised to an exponent? When you have the same base and you combine them, you add exponents. This would be n minus 2 plus 2. Well, plus 2 minus 2, those cancel out. So you're just left with sine of x to the n. So this is sine minus sine to the n of x dx. Now I hope this stands out to you. That's the function we started with here. This is an integration by parts. This is a wraparound. This is a bunch of stuff. And that's what's kind of good to demonstrate. So we, at this point, could finish up just by breaking up this integral into two integrals, right? Because you have this minus sign. You can take that entire integral and break it up into two. And then moving it to the other side. So here, I want to write sine to the n of x dx equals negative cosine. And I know it takes a while to watch me write all this out, so please bear with me. Plus, okay, we have n minus 1 times the integral of sine to the n minus 2 of x dx. We're breaking up the integrals, right? This is important. Do not forget that this is n minus 1 times this entire integral. If you break it up, right, so you have to think about it like this. If you break it up, you have to distribute that to both terms. This n minus 1 has to be distributed to both of those terms. So it's minus n minus 1 times this integral, sine to the n of x dx. If you're not careful, you're not going to see that, and you're going to leave that out, and then you're going to not arrive at the right answer. Okay, so now we just need to add this integral here to both sides. It's the same integral that we're starting with, so we just add it to both sides, and we have to add n minus 1 of them, because that's how many we have on the right side. So we have n, well, that's how many we're subtracting, I should say, from the right side. And then here you have times n minus 1, or plus n minus 1 times sine squared, no, not sine squared, sine to the n of x dx. Okay, you have one of them here already, and you're adding n minus 1 of them. So let's think about this. You have one, you're adding n minus 1. Well, that's just 1 plus n minus 1. The 1 and minus 1 cancel out. You just have n of them. So now we need to go back here and say that we have n times sine to the n of x dx is equal to negative cosine of x times sine to the n minus 1 of x plus n minus 1 times sine to the n minus 2 of x dx. And I hope you see that we're practically there. We just need to divide by n on both sides. And so we divide that whole thing by n, and we divide that by n. We will arrive at the reduction formula for sine. So you have sine to the nx dx is equal to, I'll just go ahead and write negative 1 over n out front, times cosine of x times sine to the n minus 1 of x, plus n plus 1 over n times sine to the n minus 2 of x dx. And there it is. That is the reduction formula for sine. And I hope it's not so scary now. It's still maybe kind of a beast to remember it, but at least when you know where it came from, it's not so scary. And also, I hope you see why it's useful. We start with some high degree of sine of x, and then we decrease it here. This integral right here is decreased by 2, which is pretty helpful. And then, if this is raised to something, let's say greater than 2, if this was sine squared, for example, this would be sine to the 2 minus 2. That whole thing would go away and just be 0. and then you wouldn't have to, or 1 I should say, it would be raised to the 0th power would be 1, and you just have an x out front. However, if this was something bigger, something like n was equal to well, if n was equal to 3, what would that be? Well, then you just have sine to the first. That's easy to integrate. You're done. If it's equal to 4, then you'd have another sine squared after you plugged in, right, your n for 4. And you'd have to expand this integral once more using the same sort of reduction formula. But at least it's easy if you know what the reduction formula is, just to sort of write everything out instead of going through all this work that we did up here. Because this is all the work we did up here you would have to do if you didn't know the reduction formula. If you knew what n was, but you didn't know the reduction formula, you would have to do all this, and then, you'd get to this part here where you have this sine to the n minus 2, and then you would have to, again, go through all this work to reduce the degree one more time. So this is a helpful thing to know, and it's even more helpful to know how to derive it. The reduction formula for cosine is similar, and how to derive it is similar. And just like all the others, you have to be a little bit creative, but it's worth knowing how to do it. And this is also, by the way, a good segue into trigonometric integrals, which I'll be doing 2 videos from now. The next video, I'm actually going to just do a sample of a bunch of different integration by parts problems, and we'll apply all the methods we've learned up until now to solve them. All right, see you in the next video.